Welcome 8th graders. Today we're going to try chapter 3, section 3. We're going to determine if relationships are proportional. Go ahead and write this as our objective in the table of contents as well as on top of your notes. Okay. All right. I have to apologize. My paper printed on both sides, so it'll be a lot of shifting of papers. So hold on. Okay. What are proportional relationships? Proportional relationships are relationships between inputs and outputs, and we talk a lot about inputs and outputs, right? Inputs is what you put into a machine, and outputs what you get out. Inputs are my x's, outputs are my y. Okay, so in which the ratio of inputs to outputs is always the same. This is the most important part. So the ratio of inputs and outputs, you can underline that, is always the same. This is the important part. Okay. All right. If relationship in a table, if a relationship is in a table, write the ratio of each input to its corresponding output. Even if the ratios are the same, then you can conclude that the relationship is proportional. So here's the little question. Where in everyday life activities do you see proportional relationships? When does it happen? Well, I'll tell you one. I think the most famous one is when you cook. When you double recipe or you triple recipe. So for example, if I say that for each cup of flour I'm going to use 2 eggs, so if I decide to use 2 cups of flour, hopefully I increase my eggs, I double them also, so it'll be 4 eggs. Think about other places where you use relationships which are proportional. There's many places, and that's why we are going to learn how to figure out if the relationship is proportional. Important because it's once you figure it out that the relationship is proportional, you can easily calculate information for it. Okay, so there we go. Here's my first table, and I have to determine if the relationship is proportional. So remember, I have to look at the ratio input to output. In that situation, time is my input and distance is my output. So what is the ratio input to output for this one? What's 1 to 50? How about here? Well, that's 2 to 100, which if I reduce my fraction, that's 1 to 50. Okay, that's the same thing. Here is 3 to 150. If I reduce that, that's 1 to 50 by divide by 3, right? I have 1 to 50. And then I have 4 to 240. Well, I could divide by 4, so that's 1, but that will be 1 over 60. So this last ratio is not correct, right? All of them are not the same. So I can conclude it is not proportional. Okay. As you can see, I had to do every ratio. The first 3 were the same. It's the last one which threw the whole problem off for me. So don't get lazy. Don't just try few at the beginning. You have to check every one. Okay? Every one. All right. Here's a question for you. All right. Is this relationship proportional? So I have 2 pounds of tomatoes for $3, 4 pounds for $6, and 6 pounds for $9. Is it proportional? Let's pause it, think, and come back. Welcome back. So let's look at our ratios. So 2 pounds for $3, 4 pounds for $6, but if I reduce that fraction, that's also 2/3. And 6 pounds for $9, if I reduce that, I'd both divide by 3, so it's 2/3. Do you see those 2/3? Those 2/3 every time mean that my relationship is proportional. Those ratios for those fractions are the same. Good job. All right. Let's try this one. the ratio of the all inputs to the outputs in a table are 1:4. Is the relationship proportional? Go ahead and write the answer. Very good. It is proportional because all the ratios are the same. All are 1/4. Okay, second question. Pizza slices are selling as follows. 1 for $2, 2 for $3, 4 for $5. Is this relationship proportional? Explain. Okay, it's your turn again. Okay, welcome back. Let's see. Let's look at those ratios. So 1 for 2, 2 for 3, and 4 for 5. Are those fractions the same? I hope you answered no. Because of those ratios are not the same, we can conclude that the relationship is not proportional. Good job. All right, the last question. Okay. Jewelry earns $12 per hour making bracelets. She uses the function E equals 12H to track her earnings, where E represents earnings and H represents the number of hours. Make an input-output table and graph your results. So I'm going to make my table. Which one goes on axis? Which one goes on Y? You may ask. So I'll tell you. All the x's are your inputs, okay? And outputs go on the Y. Okay, so in my situation, input is my H, so it's the hours, and earnings go on out. So I'll move it up a little bit. Okay, so hours and earnings. Okay. All right, let's try. So if I do 1 hour, then hopefully you know that it is 12 hours. I would just put that this is 12. Every 2 is 12 here on this. Okay. If I did 2 hours, if my H is 2, my earnings should be 24. Okay. If I have 3 hours, that will be 36. And so on. As you can see, it will be a straight line. So, very quick discovery here is that a proportional relationship will have a line, a specific line. And for you to find out what kind of line, we'll have a little activity I ask you to do after this video. And hopefully you will discover exactly how this line looks like. But for right now, just so you know, for this question, it is a proportional relationship because my ratios are the same, right? So let's look. My input for 1 is 12. For 2 is 24, which also can reduce to 1/12. For 3 is 36. If I reduce it, it's also 1/12. So all those ratios right here will end up being 1/12. So it is proportional. Okay, hope this video helped you learn about proportional relationships. If you have questions, please ask. Okay, talk to you in class. Bye.